So now we're moving on from just general sequences and series to starting to talk about arithmetic sequences and series in 11.2, and then in 11.3 we're going to talk about geometric sequences and series. So an arithmetic sequence is a sequence where each term is found by adding the same number to the preceding term. So if we were trying to find the second term, you would take the first term and add a common difference. To find the common difference, you just have to subtract any two consecutive terms in your sequence. So for example, I've got three sequences written here, and we want to identify what's the first term, because that's going to be important for an equation in a bit, and the common difference. So the first term is literally just the first term, so 4. But to find the common difference, you take any two consecutive terms. So you've got 4 goes to 9, and you subtract them. So you always go the second term minus the first term, and you get a common difference of 5. I could take any two terms in the sequence. So I could take 19 and 14, so 19 minus 14, and I still get that common difference of 5. So no matter which two consecutive terms you pick, you get the same common difference. So if we look at this next sequence, again, the first term is 34. If I want to find the common difference, I could do 27 minus 34, and this time I'm going to get a negative common difference. So 27 minus 34 is negative 7, and I could take any two. So even if I took negative 1 and I took away 6, I get negative 7, which means that in this sequence, you're subtracting 7 to get each term in the sequence, or you're adding negative 7. All right, last one. You could pause the video and give this one a go. First term is 2. Common difference is 2.5 minus 2, which is a half. All right. So now what we want to do is, instead of having to come up with some random equation where you have to look and be like, I think these are squared, or maybe these are times by 2, there is a general formula for finding any term in an arithmetic sequence. And how it goes is that you can find any term, so the nth term, by taking the first term always and adding your common difference a certain number of times. So for example, if I wanted to take this sequence and I wanted to say, well, what's the general equation? You're not going to know the nth term or n, because that's what you're going to be solving for. Like maybe you want to know the 14th term or the 13th term, but they'll always be given a1, so the first term, which in this case is 4, and the common difference you can find by taking any two terms and subtracting them. So this one has a common difference of 3. So the general equation would be an equals a1, which is 4, plus n minus 1 times that common difference of 3. So technically this is great. This is an awesome general equation. I really like it in this form. If you were going to use it a ton, you'd want to simplify it. So for example, you could just distribute your 3 and get 4 plus 3n minus 3. So you'd get 3n plus 1. So you could say that your general formula, or to find any general term, is an equals 3n plus 1, or you can leave it in this form. If it's multiple choice, you'll have to see which one it wants, okay? But what we're going to do is use it. So we're going to use this general equation to find different terms. So if I want to find the 14th term, you're going to use an equals 4 plus n minus 1 times 3. And I'm going to plug in 14. So I'm going to find the 14th term, which means I'm putting in n as 14. So the way that this equation works is that you're taking that first term 4 and you're going to add 3, which is your common difference, a certain number of times. So if you're finding the 14th term, you're going to add 3 13 times. That's why the equation has an n minus 1. And then you just do it. So 4 plus 39 is 43. I had to think about that one for a second. Okay, so you could do that. I mean, if you wanted to use the other formula, you're going to get the same answer because this is just the simplified form. So if you're finding the 14th term, you could do 3 times 14 plus 1. 3 times 14, I need to use my calculator, is 42. And 42 plus 1 is 43. All right, so now what I would like you to do is pause the video, and I want you, for this sequence, to find the 21st term. So you're going to use the general equation, an equals a1 plus n minus 1 times d. You're going to plug in for a1, n, and d to find the 21st term. Okay, go. So hopefully you paused it, okay? And so what you would do is you're putting in n is 21. The first term is 0.17. putting in that n value of 21 in here, and you got to find your common difference. So the common difference would have been 0.12 minus 0.17, which is negative 0.05. And then you plug that in, 0.05 negative, and you calculate. So I'm going to use my calculator. I put in 0.17 plus, now I'm going to do 21 minus 1 in my head, so plus 20 times negative 0.05, which gives me negative 0.83. So the 21st term in this sequence is negative 0.83. All right, well, what else can we do? Well, maybe instead of asking you to find the 21st term, they're going to say, hey, one of the terms in this sequence is 301. What term number is it? So we're going to use that same formula. We're going to use an equals a1, so first term, plus n minus 1 times the common difference. This time they're going to give you the nth term. The nth term is 301. First term is still 4. I don't know how many terms there are, or what term number it is, but I know the common difference is still 3. So 7 minus 4, which is 3. And I just plug it all in. So I'm going to plug in 301 is equal to 4 plus, I don't know, n, and the common difference is 3. All right, and now we just rearrange and solve a linear equation. So I'm going to subtract 4. So 301 minus 4 gives me 297. Now I'm going to divide both sides by 3. So 297 divided by 3 gives me 99. And then I'm going to add 1 and get 100. So 301 is the 100th term in this sequence. All right, I want you to pause the video and I want you to find what term number negative 644 is in this sequence. Hopefully you're coming back and you use this formula, because this is the formula you always use in an arithmetic sequence. And so we're going to say that negative 644 is equal to the first term 7, plus, again, we don't know n, but we know that our common difference is 4 minus 7, which is negative 3. And then we just solve. So negative 644 minus 7 gives me negative 651. Then we're going to divide by negative 3 to get me 217. And then I'm going to add 1 and get n is 218. So negative 644 is the 218th term in this sequence. All right, the last thing that we're going to do before you go and practice some is construct sequences. So sometimes what they'll do is they'll say, okay, well, we know the third term and we know the 16th term, and they want you to find the first term, the common difference, maybe they want you to find the 18th term, you know, something along those lines. There's two ways of doing this. One is very algebraic. So they've given you two general equations. The first one is when the third term is 8. So the third term is 8. So if I want to plug that into the equation, the nth term is equal to the first term plus n minus 1 times d. What do I know? Well, I know the nth term, or the third term, is 8. I don't know the first term, but I do know that it's the third term, so I'm going to put in n as 1, and I don't know the common difference. Then I'm going to do the same thing with the 16th term. So they're also telling us that the 16th term is 47. So I'm going to plug in 47. I don't know the first term. I know that this is the 16th term, and I don't know the common difference. So now what's happened is that using this general formula, I've come up with two equations with two variables. If you remember way back to Math 11, is that when you have two equations with two variables, you can solve by substitution, elimination, or graphing. So I'm just going to first of all take this equation and make it simpler. So I'm going to do 3 minus 1 is 2. So I've got 8 is equal to the first term plus 2d. And for this equation, I've got 47 is equal to the first term plus 15d. It's the easiest to solve this one by elimination. You could subtract these two equations right now to get rid of a1, or you can take one of your equations and multiply by negative 1. I'm going to multiply my top equation by negative 1 just because it's got smaller numbers. So I've got negative 8 equals negative a1 minus 2d. and then my other equation stays. 47 is equal to A1 plus 15D. Now I'm going to add these two equations. So negative 8 plus 47 is 39. Negative A1 plus A1 is gone. And then negative 2D plus 15D is 13D. So to find the common difference, I can now divide both sides by 13. And I end up with D is equal to 3. Once you know that your common difference is 3, you can plug that into one of your two equations to solve for A1. So I'm going to take this and I'm going to plug it into the simplified version of the first equation. So that's going to give me 8 is equal to A1 plus 2 times 3. So I've got 8 is equal to A1 plus 6. I'm going to subtract 6 from both sides and I end up with A1 is equal to 2. So therefore, the first term is 2 and the common difference is 3. Okay, now I said there would be another way of doing this. So again, this is the very like algebraic, if you're very formulaic way to do it. But there's another way, and the other way is graphic, not graphically, but kind of showing the picture of it. So they're telling us that the third term is 8. They're telling us that the 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16th term is 47. What we want to do is figure out the common difference and the first term. So to get to 47 from 8, this is the third term. This is the 16th term. We have to figure out how many times we're going to add D. Well, you can look at it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 times. So we're adding D 13 times, which makes sense, to get from the third term to the 16th term. So we write that as an equation. 8 plus 13 common differences will give me 47. So then to solve for D, I'm going to subtract the 8. I end up with 13D equals 39. That feels familiar. I'm going to divide both sides by 13 and I get D is 3. So I added 3 13 times to get to 47. But that's the common difference, and I still want the first term. So to go backwards, instead of adding our common difference, we could subtract the common difference. So I'm going to subtract the common difference twice, and I end up with 8 minus 3 is 5, minus 3 again is 2. So this is your first term. Or you could have made your equation, right? You could have used an is equal to first term plus n minus 1 times d. And now I knew the D, so I could have found the first term by plugging in 8a1, 8 minus 1 times 3, and then solving for a. So totally up to you, however you want to solve the equation, or however it makes sense to you visually to be able to see how this would work. Feel free, but there's lots of practice. So now I would do the quick check, go to page 84 and do those questions at least. Good luck.